Let's have a look now at the analysis of manipulation and attention checks and the ideal sequence of steps that need to be undertaken if you have both in your experiment. This video also assumes that you watched the first video that I made that explained what manipulation and attention checks are. If you haven't done that, please pause this video, watch the first video, and then continue with this one. In developing this video, I consulted the work by Berinsky and colleagues, which was published in 2018, which you can see at the bottom of this page. If you're interested to learn more about this work, please do so. It's a very comprehensive work. It includes the sequence of questions that researchers need to include in the experiments. It also covers the steps that are required in the preparation to an experiment and also during the actual administration of your experiment. It's a very good resource. Okay, on the screen, what you see is the typical sequence of an experiment, what an experiment would follow. You would give your participants an introduction to your experiment. You'll give them instructions without giving away too much. Everything depends on your research design. This will be followed by the administration of your actual manipulation. Then you would measure your dependent variable, ask them to complete any other required measures. If you plan to use an attention check, it would be somewhere after you measured most of your questions, and manipulation check will be administered at the end of the experiment. Then you would think, debrief, and end your experiment. So let's say you ran your experiment, you collected all your data, but before you analyze your data, there are several checks that you need to conduct, and this is what I will be covering now. What should be the analysis sequence before you start testing your main hypothesis? Berinsky et al. Discussed attention checks, manipulation checks, and checking the time as one of its quality checks simultaneously. Although their work did not prescribe any particular sequence for the steps, I have organized them for you in the order that is shown on the screen for a bit of clarity. My personal preference is to begin with the time-based completion quality checks. This is because I want to ensure that I retain only those participants who spend an appropriate amount of time on their experiment. And that aligns with the expected or required time of completion, because this can ensure that my manipulations were paid attention to, they were processed thoroughly and attentively, again in theory. Timing is especially critical for some of my experiments because I look at the decision making which occurs quickly or in real time. And if participants completed the experiment too fast, they may not have properly engaged with my manipulation or with the follow-up questions. Conversely, if they've taken too long to complete my experiment, it may also indicate a lack of attention and the deviation from my research instructions, which can also compromise the quality of my data. So for my own peace of mind, I exclude participants who fall outside the expected time range, so they completed too fast or too long. However, if your experiment does not require a particular time frame, you can be more lenient, of course. However, keep in mind that sometimes even after 30 minutes, consumers may not remember what they actually read. So timing is often very critical and is an issue in experimental research. So how do you determine what counts as too fast or too long? You should first pretest your experiment. Share it with your friends, family, or colleagues, typical consumers who are likely to take part in your research. And it's best to involve several people because some of them may read sentences too quickly, some of them may be slow readers. So if you give it to several people to complete, it will give you a really good average estimation across different people. And you use this estimate as a guidelines to judge who has or who will complete your experiment too fast or too long. Determining who completed your survey too fast or too long could be a bit different if you deal with panel providers. In other words, companies that give you access to real consumers. So what you see on the screen here is actually my personal experience with panel providers. Panel providers, in my case, were reluctant to remove at no cost the participants who took too long to complete my experiment. But they were more willing to replace those who completed it too fast. And based on my personal experience, panel providers treat those who completed my experiment 1/3 of the median time as the ones who completed too fast. And then they would replace those at no cost. However, I encourage you to talk to your panel providers when you source your quotes, explain them your research design, your research protocol, what your guidelines are, to identify what they would consider as speeders, what they would consider as people who took too long, and whether they would replace those who took too long at no cost. So keep in mind that median, which is here actually shown on the screen, also includes people that completed your survey too long. So 1/3 of the median, of course, would be a bit often a skewed estimate and may not always be great because it will be inflated by those who have taken too long to complete your experiment. Let's say you remove people who've taken too fast and too long to complete your experiment, and now you're ready for the next step, which is, in my case, attention checks. And my personal preference to start with attention check is because if you actually move all the way to the analysis of manipulation check and then you move to the attention check analysis and realize that you have to remove several people, you basically wasting your time because you have to go to this step again before you can move on to the analysis of the manipulation checks. So do not waste time. In research, time is always an essence. And if I were to have a conscientiousness check, I would place it at the end of my research protocol, and I would follow this paper as a guidelines because that's how they've done in the past. Then if I have conscientiousness check, which asks people whether they take questions seriously, I would then analyze answers to this question first, and I would remove people who said, no, I did not take your experiment seriously. And only then I would move to the attention check. Why would I do that? Exactly for the same reason that if you find that after the analysis of the attention check and you move to conscientiousness check that there are some people you have to exclude, it means you basically wasted your time. So this is my preferred sequence if I have conscientiousness check, attention check, manipulation check in my research experiment. Just as a refresher before we turn to more technical aspects, I want to remind everyone that manipulation checks must not and cannot be used as your independent variables or as your mediators or as your moderators in your experiments. This is something that we test before we analyze our conceptual framework, but in no case manipulation checks form part of your overall conceptual framework. As another refresher, before we move on to more technical aspects, I wanted to talk about manipulation checks when we have multiple factorial design in our experiments. In other words, we manipulate several independent variables. Just like here on the screen, I have a pill type, which has two levels: kinder schema manipulation, where participants are shown a child, and a control group, which shows stationary. And the kinder schema manipulation then also has different levels for peer commentary, which can be either positive or it can be negative. So if you have more complex experimental design and you are manipulating several variables such as appeal type and the commentary type, then as part of your manipulation check, you need to check whether your manipulation worked as intended for each of the independent variable, and also that there is no interaction between your manipulations All right, let me demonstrate this to you using an example. What you see here now on the screen are the examples of two manipulation checks that can be included. One for the appeal type manipulation, where I'm asking people whether the message that they've just seen showed a cute child or a pen. Those who were allocated to the kinder skill manipulation should be actually answering around here. And then for my peer commentary, those who are allocated to kinder skill manipulation, then they would see these type of a question, asking them to measure or to appraise the commentary that they saw, whether it was negative or positive, or was not very favorable, or was quite favorable. So first, as a researcher, I actually need to ensure that all my participants understood that they were exposed to kinder schema or a pain. So I am looking now at the first manipulation check. Also, I need to ensure that those who were allocated into the different peer commentary condition also understood manipulation in either positive or negative way when it comes to the commentary. And I would need this to ensure that my manipulation worked as intended. So first, in line with the literature, I would first analyze data for the first manipulation, which is this question, and then I would analyze data for the second question. And how would I actually write it up? Because I have two groups here, I would use an independent sample t-test. So here on the screen, you will see an example of how I would write up results for independent sample t-test. If everything worked as it should have worked, then you can say participants allocated to the kinder scheme manipulation, and in brackets you would put the mean for it, were more likely to agree that they saw a child, whereas those who are allocated to the control group were more likely to agree that they saw a pen. And then you would put the mean for the participants allocated in this group for this question. Then you would have your t statistics and the p-value. And importantly, you would say in the end, confirming that the manipulation worked as intended. How would you write up the results for the second manipulation check? Again, if there are two groups, you would use an independent sample t-test. If data is normally distributed, if not, you would use other types of tests to account for it. If everything worked as it should work, then you can say participants in their schema manipulation with the negative commentary rated commentary as more negative, and then you would put the mean for this group compared to those who were allocated to the positive commentary condition who rated it as more positive. And then you would put the mean in brackets for people allocated to this group in their answers to these questions, which you can use individually or you can aggregate it. It's completely up to you. And at the end, you would say confirming that the manipulation worked as intended. Let's have a look now at the actual analysis and the sequence in more practical and technical aspects. Let's stick with our simpler experimental design where I have only two groups, kinder schema and the control group. Here on the screen, I have the example of the attention check that are used, which I should analyze first, then factual manipulation check, that's my personal preference, and then the subjective manipulation check. And now let's have a look at the attention check. In terms of how we would analyze the data, of course, we would use descriptive statistics. In this case, here, what do you need as a researcher? You need to identify and develop research protocol where you would identify the correct answers for each of the participants allocated to each of your experimental conditions. And what are those correct answers? Those who were allocated in the kinder schema manipulation should select strongly disagree, and those who were allocated to the control group also should pick the same answer. And any other answer option would be treated as incorrect answer. So in theory, you should discard those people. However, several papers such as by Geuens and de Pelsmacker, Mayavis and Van Osselea and Oppenheimer recommend discarding people who fail the attention check with a lot of care. Berinsky in 2014 work actually recommends researchers to test their hypothesis in other words, their main conceptual framework, using the full sample that has people who didn't meet the attention checks, and also on the clean subsample that has these people removed to see what is going on. If several screener questions are used, researchers need to present results stratified by the attention check. So, what this whole academic discussion is calling for is discretion and a lot of care when we deal with inattentive respondents. And I would also encourage you to check your discipline, your leading journals for guidance when dealing with people who didn't pass your attention checks. Let's have a look now at the analysis of factual manipulation checks. Of course, you would use descriptive statistics again in this case. And as a researcher, you would need to develop research protocol to determine what would be the correct and incorrect answers for each of your groups that you had. Here on the screen for this type of question, you would expect that if people paid attention and they were reading questions and they were actually observing what was on the screen for them, they would pick acute child answer if they were allocated to kinder scheme manipulation, and then they would select stationary if they were allocated to the control group. Stationary and did not show anything will be deemed as incorrect answers for kinder schema group, and the cute child and did not show anything would be deemed as incorrect answers for the control group. For the analysis of subjective manipulation checks, which actually involve a bit of a rating scale, you would use independent sample t-test if you have two groups, which I do have in my case, as you can see on the screen, or you would use ANOVA if you have more than two groups to test the mean differences. Here again, as a researcher, you need to determine what is the correct or expected answer for your respondents to pick depending on the group that they were allocated to. Hypothetically, because this is an agreement scale ranging from a cute child on one end and a pen on the other one, those who were allocated to the control group, which is my pen or stationary condition, they should be selecting answers 5, 6, or 7 to actually confirm that manipulation worked as intended. And answers ranging from 1 to 4 should be sort of treated as incorrect answers for this group. And the same logic would apply to the kinder scheme manipulation. You expect people to select these type of answers and not 5, 6, or 7. In theory, this is easier said than done, because what should you do if you have response patterns like this? And let's say your control group has a mean of 4.1 and your kinder scheme manipulation has a mean of 2.6. All of them are statistically significant and different from each other. Would you then deem 4.1 as an acceptable answer? They are indeed statistically different, but does it meet your researcher requirements? What would you do in a situation where 6.8 is the mean for the control group and 3.2 is the mean for the other group? I would say this is sort of okay. What would you do if you have a mean of 2.9 in the control group and 1.5 in the kinder scheme manipulation? Obviously, something is going wrong here. So you should not be accepting this type of responses. Like I told you in the beginning of this video, I will also expose you to some very uncomfortable situations, a bit of a nightmare in experimental research, where things do not go as well as expected. And I will stick with this scenario where I'm looking at attention checks and factual manipulation checks at the same time. So I'm doing my analysis simultaneously. This would be my preference to get a better understanding of what is going on in my data. And only once I identify participants who need to be retained, I would then look at my subjective manipulation check. So as you can see here, I have quite a nasty design for you, because in the group which actually met the attention check, I also have one person who picked incorrect response on the factual manipulation check. And also in the people who didn't meet my attention check, I then have people who have correctly identified the factual manipulation check response to it. I have it in yellow for you on the screen. I have 10 participants who picked the correct answer here, and 5 here, and also 5 here. So that presents a bit of pickle situation for you as a researcher, because now you are trying to identify, well, if I am going to discard these people, I am losing about 20 people who have correctly identified the answers on the factual manipulation check, which in fact was asked later in my experiment. So, what should you do? And all of these actually brings us to very operational and pragmatic decisions about the experiment, because it's all about the sample size. You want your sample size to be quite balanced between the groups, between experimental conditions, so that it doesn't compromise your statistical data analysis. And what to do in this situation? I'm going back to Spilsky, who actually cautions researchers about such situations. They suggest that removing those participants where the treatment was unsuccessful can easily result in confounding your results, which means that you're retaining only the people for who the manipulation actually works. So you're kind of inflating the results of your research. That's why they caution against mindless removal of the participants, and they suggest to develop a very detailed and logical research protocol to explain who would qualify to be part of your sample, even if they haven't met some of the required attention checks. So if I look at all of these nightmares that I currently have on the screen, what would I do as a researcher? Now, this is my personal preference. I would definitely remove these people because they paid attention to the question, but on my actual factual manipulation check, they made a mistake. In this case, I cannot be sure that they were not on the screen on their phone and that they actually saw the message that they were supposed to see, that they processed my manipulation quite thoroughly. So I would definitely remove these people. Now, with these ones who are in yellow color, here I'm actually less sure about it. And the reason is they actually paid attention to my manipulation check, to the picture of the child that I exposed them to, but then they failed the attention check later on in a survey. In this case, what I would do, I would actually stratify my sample and I would test my conceptual framework on the total sample that includes everyone. Then I would test it separately on a sample that excludes these guys, and then on a sample that excludes these guys, and then on a sample that excludes these guys and these guys. And then I will see what's going on in my data to really understand whether people made a mistake or they genuinely paid attention to my manipulation and then made a mistake later on. It is a situation that requires a lot of discretion, discussion with your colleagues, and using a lot of logical sense and looking at what your data is telling you. So you need to sink your teeth in data, understand what's going on. Do you genuinely have inattentive people, or they correctly answered your manipulation checks here and then made a mistake later on? Now, this was a very technically heavy video, but I hope now you understand the sequence of the questions that go in the experimental design, and you also understand how to analyze your attention check, your manipulation check, and also the sequence of those questions and procedures, how you should go about it. And I also hope now you're aware of the fact that things not always go as planned, as expected, and you may find out some uncomfortable situations or scenarios during your experiment where you will have to discard some people from your sample. So what I usually do, I recruit 20 or 30% more people to account for those that I have to potentially discard in the future, so that I have balanced sample for my main data analysis. I hope you enjoyed this video. I hope you still enjoy and love experiments like I do, and I will see you in my next video.